So I like little artificial life things, so I created something with a bunch of ants wandering around. So here's ants navigating their way around in the ant world. And you can see it's running really fast, right? We've got tons of frames per second. The JS in this abstract meter is running very fast. And this is the kind of thing that the tracer is great at. We have kind of one fundamental task. The TraceMonkey engine takes that to native code and just runs it super fast. But the problem is, it can only sort of handle so many tasks at once. So if I add another task here, like say picking up bits of pizza and carrying it back home, you see that now it's actually, it's not too bad, but it's not all that fast anymore. And that's because there's too many tasks, so some of them have to run in the interpreter, which is much slower than the tracer. So I can add even something else, so now I add a little spider. And for reasons that are kind of obscure, it actually speeds up for a little while. Eventually this new task comes in, right? Making the ants red and angry and chase the spider, and suddenly it's just extremely slow, right? You would not say this is fast. So in the time-honored tradition, the way that we're fixing this problem is by adding a new monkey. So Jaeger monkey is what we call this monkey. This is just an early build from our Jaeger monkey branch. So Jaeger monkey optimizes things in a simpler way, so it can basically make everything fast, but sort of not quite as fast as the tracer. So this is kind of an early build. You can see the JS not running as fast, but it's still fast enough to make this app run well. And pretty much no matter what I do, the speed is really just going to stay about the same, because it sort of optimizes everything at once, runs in the same way. So I can even send a spider on. Stuff happens here, we're just still pretty fast. So that's what we want to do. We want to be sort of always fast from now on. So the same idea applies if you look at, say, some popular benchmark suites, right, that people are always comparing browsers with and stuff like that. So here's just a couple I picked out. One on the top happens to be one where TraceMonkey runs it, and it's super fast, and it's great. The one on the bottom is something that TraceMonkey can't run because it has about a zillion tasks, and so we go back to the slow interpreter. But with JagerMonkey, instead of having that slow interpreter, we'll have the JagerMonkey system, which on the top actually is fast, even without tracing. And on the bottom, we're fast there too. So then the last piece I wanted to show you is, say, something on the actual web that's sped up by this, which is a little hard to find because Fast.js is kind of a new thing. The web's not really using it fully yet. But there is this one. So this is actually a Nintendo emulator. So you're emulating this entire 80s hardware device. Tons and tons of tasks for all those components. And if you tried it in Firefox 3.6, you get 10 or 20 frames a second. So barely playable, but not really a game. And now I will demonstrate the fact that I cannot, in fact, simultaneously play Super Mario Brothers and give a demo. But you can see right here that we're running at 60 frames a second, and it looks great, just like on your So there you go. So looking ahead, right, what we're going to have now is two ways of running JavaScript. We're going to have the JagerMonkey, which makes us fast all the time, and then we're still going to have TraceMonkey, and then when that kicks in for things that it's good at, we'll be even faster. So thanks. Back to Dave.